Hi everyone, this is Judy Warner. Welcome back to the OnTrack podcast. Today we speak with Amit Bahl, who's the Director of Sales and Marketing at Sierra Circuits. He talks about their more holistic view because they not only fabricate boards, but they assemble them. And he's going to teach you ways to really think more about your total cost of ownership. We have a little fun too, doing some myth busting around PCB fab and assembly, and I think you'll enjoy it. Make sure to stop by their website after the podcast. They have some amazing resources for designers there, and we'll put some for you in the show notes too. Lean in and enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, Amit, thank you so much for joining us today from Sierra Circuits in beautiful Sunnyvale, right in the middle of Silicon Valley. We're delighted to have you and learn from you from all the years of being beat up in the circuit board industry.
That is true. But do I look beat up? I think
No, me today. Too. No, I have makeup to cover up the bruises. I have stuff to cover it up. So
where's my makeup? Oh, I'm just kidding.
So, why don't you start out by talking about your industry in the electronics industry, and then tell us a little bit about Sierra.
Sure. So, well, my story is pretty simple. I'm here to service PCB designers. Whatever they want, whatever they need, that's why we're here. Our business is quick turn. So we do PCB fabrication, we do assembly, we do component procurement all really quickly. That's our business. And we have a lot of customers who need that, and we've been around for 30 years, manufacturing everything in sunny Sunnyvale, California. Most of the time sunny.
Yeah.
So, that's our business, and that's what we do. So whatever a designer needs.
How long have you been at this personally?
So my dad started the business in '86. So I was spending my high schools setting up drill machines for drilling holes in circuit boards and packaging circuit boards. And so I got my training early on, let's just put it that way. So.
Yeah, you know what? It's really funny. There's probably at least half a dozen people that we've had on the podcast that's exactly how they started. Absolutely. It's funny how that business ends up being very multi-generational, but it's cool. I love it. I think that sort of the passion gets passed on that way. So, well, you said you do fabrication and assembly. Do you do that all in that same plant there, or do you have more than one facility?
We pretty much own the block on Evelyn Avenue in Sunnyvale. So we have a few buildings where we do our fabrication, our assembly. We house materials and our sales and our, HR and all that. So we have a few buildings on Evelyn. So okay. Yeah, it's like
I've been there, but you've never walked me through the shop. I'm feeling a little jilted. What the heck?
We need to do that. We need to do that.
I always come see you in the office, or
yeah.
I haven't really actually been on the shop floor. So next time I'm up, buddy, you owe me. Okay, so what I thought would be interesting to talk about today, because you do fabrication and assembly, that I would imagine I have worked in fab and assembly, and we tend to stand in these sort of siloed places, right? But I think because you do both, it sort of gives you a unique perspective. So I wanted to share with our audience today sort of the things you think about and what kind of things they could do to help get their jobs done faster, better, cheaper, more reliably. So what are some things that you sort of look at, more in a holistic perspective, I'd say?
Yes, I would say that's a great question. So it's like everything you learn over time. So a designer or a company that's young at doing electronics or just starting out, there's a lot of mistakes to be made. So we help like prevent as many of those mistakes as possible. There still will be mistakes, but we're trying to really get it to a minimum. A company that's more mature, who's gone through it, over time, they've kind of gone through all their growing pains, and now they know what they're doing. So
yeah, true.
They're fine. So we help more in that younger kind of space. And what we see is that people don't look at it, like you said, holistically. Mm-hmm. So, if you're doing an assembly after a board is made,
yep.
right? You have no choice but to assemble the board you got.
Right.
There's no choice.
Yeah.
So, a lot of the times where there could have been good feedback going from an assembly facility back to the PCB prototype facility, mm-hmm. It just doesn't happen because there's almost no point. The board is there, you got to assemble it. They do it, they're done, move on. Mm-hmm. What we noticed as soon as we opened our assembly facility was that they were cribbing about everything. Like, hey, why'd you do it that way? And what's going on there? And can you please stop doing that? So we learned very quickly through that feedback. I mean, we've been making circuit boards for 20 years before that time. Right. And no one ever told us anything. As soon as we have our own
there's
assembly
the
shop,
silo. Yeah.
Yeah, exactly. So we saw that right away. I would say the number one thing where customers make mistakes is their arrays. So if you have an assembly shop that you're going to, they're going to want boards to come in an array. Yep. Because it's more efficient for assembly process. Mm-hmm. Instead of pick and placing one board, you get to pick and place 6 at the same time. So,
and you don't have to make, railed, fixtures, right, to take them through. Also, it's not efficient to do one up.
Exactly.
But then if you're a board manufacturer, you're like, yeah, do them one up. Here we can score them. Get more up on a panel, but that's not including, if you're not looking at assembly, that's not including the rails that, help you do 4 up in an array,
yes.
which is more efficient on the assembly side. So.
It's more efficient on the assembly side. And guess what? When people were ordering just PCBs from us, they would forget to send the assembly drawing or forget to send the arrayed panelized drawing. Mm-hmm. How do we know?
Right.
So we're building, individual boards. They get them. The assembly house gets them, and they're like, we just bought the stencil for the array. We programmed the machine for the array, and we're getting individual boards. Geez, this is going to delay your project. Whatever happens. So I would say that's the first learning. So now for our customers, we do the array for our assembly house.
Okay.
So customer doesn't have to worry about the array anymore. They don't have to worry about where things are placed or whatever. We'll take care of all of that. They get an individually assembled good board, if that's the way they want it.
Right. So you sort of take that off their plate, which is...
Yeah, because
and you make it, so it will go all the way through fab straight through to assembly without
Exactly. Mm-hmm. And making an array sounds trivial and simple. It's not. Mm-hmm. Where do you put those tabs to hold your individual board in that rail is super important.
And how you break them out too, what kind of components you have, right? You go mechanically, snapping those apart, and whoops, a component goes flying off, or you have side mounted connectors, right?
Yes,
those are hard, right?
Exactly.
So
yeah, people don't think about that. If you pop a board out after it's been assembled from a rail, that force is not good.
Not good.
Yeah, so people don't know about that or think about that, I would say.
Yeah, well, I think that's something good for our audience to know. Arrays, okay. That's a really good one, and it's really a big deal, like you said, especially if you go out and, whether you're making a stencil in-house or you go out and have a stencil made, and then you have to make another stencil. Time... cost, it all backs up, right? And if it isn't done properly and you have to mechanically pop things out, then your yield goes down, maybe your price goes up over time. So lots of little things to think about. So
absolutely,
you and I sing the same song, which is talk to your fabricator. You're while you're designing your board. which
Absolutely.
almost never happens, but we can still wish, huh? What about, let's talk about data. So you just mentioned that some people don't provide, the data package with the assembly up front during fab. So for you, Amit, what data do you really need up front?
So there's data that you need for quote, and then there's data you need to actually manufacture. So data for quote, it's never complete, which is fine. It's just for quote. But important things, Gerber data or ODB data or IPC 2581 data, that's always great to have at the quote stage. And then there's everything that's not in your data. It's like, okay, material, surface finish, any sort of special requirements on your circuit board, period. Those should all be detailed out in a fabrication drawing.
Well, don't you need to know, material specs before you quote, though, right? Rogers versus FR4, right?
Yes.
So some of that you will need during the quote stage, but maybe not in full detail.
Correct. So if it's just like a README file with a bunch of stuff listed out, that serves its purpose at the quote stage.
Okay.
At the manufacturing stage, you should have a complete fab drawing. Material and PCB stack up is like the number one thing. If you care about your PCB stack up, if there are special requirements like impedance or dielectric control or whatever, then we definitely need a PCB stack up. But that's enough. Things don't have to be perfect. You could still be moving around traces and finishing up your routing and all that. That's not a problem at quote stage. At manufacturing stage, of course, everything has to be perfect.
Right.
And perfect's hard to achieve. So
you're telling me. I know. This is why I color my hair, because it's all gray under there.
You definitely look perfect.
Thank you. It's an illusion. I cover up all my gray hair. So you and I have, again, kind of, I started to say that I used to say this all the time, and then I say, well, I rant about this, and now I'm just going, let's be honest, I whine about this, about go to your board shop, work on the front end for all these reasons and more. Like, there's so many hidden little things that especially because so many EEs these days are laying out their own boards. And there was a time in history where board layout people were specialists, and they knew a lot about the fabrication process because they spent a significant amount of time in a fab shop, and people don't for whatever reason. So something I'd like to explore with you. Yeah. Again, I felt a little bit like this is therapy for you and me more than anything else. But why do you think, you personally, why do you think it would be so beneficial for an engineer designer to come see their board shop and their assembly shop?
Oh man, I could go on for hours about that.
I know,
one.
I figured.
So let's just say that this conversation is going to help me get through my day.
See, I told you, it's therapy.
Who cares who listens to this thing, as long as, you and I
think I should change this to OnTrack PCB Therapy 101.
Totally. For all the scars in the industry.
Yeah.
Well, I think one of the problems is that designers think if they know their software that they're done. Like, hey, I can design a good circuit board because I know my layout tool very well. And people like Altium are known for ease of use and designing pretty complex boards. And if you perfect your Altium software usage or automate things or configure it right, all of a sudden you're done and your job is over. And no, I can't tell you how many people finish up a design on Friday, they're about to go on a vacation, and they send it over and they're like, I'm done. Yep. I'm out of here.
I'm out.
I'm driving to Tahoe or wherever they go. Yeah. Mm-hmm. And 2 hours later, we're calling them like, hey, you forgot something. where's your assembly drawing, or where's your drill files? You can't make anything without drill files.
Right. And
So
they're like, yeah, and I want my boards next Tuesday. It's Friday.
yes,
When I
yeah.
get back from my 3-day weekend at Tahoe, I just want to pick those things up on Tuesday, whatever. Or a week from now. And you're like, I don't have everything I need.
Yeah.
So
I
how
think,
going through a shop helps them understand
yeah.
why?
So yes,
Yeah.
why that? Yeah. So the point is that you're not done when you finish designing your board, right? Like getting the data over to your manufacturer first is step one. So making sure that data package is complete. Once that happens and there's like we're going through the data in detail, we're looking for errors, we're looking for mistakes, we're looking for discrepancies. Both within the design package itself, as well as what is not manufacturable according to our, let's say, known capabilities. And this is where visiting a fab shop really comes into play. Like, making a board is not
For the
not
faint of
easy.
heart, it's not
Not
easy.
It's not easy, and it's not done by a bunch of robots like running around. Like there's people handling the product, right?
Yeah.
So when people are handling the product, you can tell there's going to be variation, and even the equipment that we have to manufacture a circuit board, tons of variation. And for a designer to walk through a fabrication house and see where the variation can come from, now they know why they shouldn't drill so close to that copper pour. Well, there's something called, true position of the drill, and how much is the drill going to wander, and etching of the copper. Those two things are separate departments in a fabrication house. So, it's hard to line those things up. So every process has a tolerance when you're making a circuit board.
Yeah.
That's like the main thing.
Yeah.
Knowing that.
And by the way, I say this often to your point of that designers tend to think if they master the design tool, they're golden, is Altium, along with all other professional tools, give you so much flexibility to design that it'll allow you to do really stupid things. You can make a beautiful board that is entirely unmanufacturable. There is nothing in our tool that says, I'm going to raise a red flag. This isn't going to etch well. Or the drill wander is going to be an issue. No, none of that is built in. In other words, the tools assume the designer knows what they're doing in regards to design for manufacturing. And, I think I'm going to share this in the show notes. I did a podcast with Kelly Dack a while ago, and he did a really neat thing on what is design. And his point as a designer is that your job as a designer does not end when you output the data, that you actually have to understand what all the secondary stakeholders need, like fab and assembly. That's actually part of your job, and over time we've sort of lost that sense.
Yes.
And so everything you're saying reminds me exactly of the things that Kelly Dack was saying. And so if I hear you right, you're saying if designers go through a shop, the light bulbs go off, and it will actually impact the way they design. They will start inherently designing for the manufacturing process, not only in fabrication but assembly as well.
Absolutely. So there's only so much equipment can do. So we have great equipment, but again, the equipment, those are all in silos. So what makes a good PCB fabrication shop is actually how all those silos are connected together. Meaning, if I'm mechanically drilling to your board, how close is that mechanical drill to then a laser drill? But the laser drill is in a different department. So how does the laser drill know where to laser drill? It's after the mechanical drill has been done. It needs to re-register to that, and all that kind of. As you walk through a facility, you kind of get that sense that, okay, this is why there are tolerances, because How do things talk to each other? And the best part about this whole thing is that PCB materials, they all move around. They're never consistent.
Yeah.
That's crazy, but it's
crazy.
True.
It's like shooting at a moving target all the time.
Exactly.
And if it's humid one day,
yes,
or if it's super hot one day,
yes.
That can affect the way the material moves on a given day.
Absolutely.
So it's tricky. So
hence don't design things too close together.
Yes, yeah.
Keep a lot of space between everything, and you should be good.
I know, and God bless our listeners. They're getting so much pressure on the backside, and plus, I feel like because of IC design, the precision that we can get, like an IC design, people think, they should be able to have that kind of precision in fabrication, and no, it's not the same animal.
Doesn't happen.
So,
I think if you bring up a good point. I've always, just Moore's law. The density of ICs has just been, going up exponentially. PCBs, the technology has been pretty much the same. We're just kind of like trudging along.
Yes, it's true. Like now we have laser drilling, or we have laser direct imaging, but these are really incremental changes to existing technology, right? They're not, it's, there's been no gigantic thing done in 50 years, right? That has allowed us to get those smaller and smaller geometries. So we keep really doing amazing things with the limitations that we have.
Absolutely.
But it's not. It's not the same as an IC, and it's not being done on a wafer.
Yes.
That is much more stable in a very controlled environment, and so on and so forth. So it's a funny thing. Yeah,
and one other thing, the circuit boards that are closer to the chips or the ICs, the substrates, the PCB substrates.
Yeah.
I mean, those factories have invested billions in being able to make that type of circuit board. And then that's all they do.
And their margins, by the way, are much bigger than they are, say, for fabrication or assembly. Like, I don't know what their margins are, but I know they're much, much larger because they sell in mass. And so we are also limited by the amount of investment we can put into PCB technology, because we're not. And some of this is better in high volume production shops, maybe in China.
Right.
But even though those things seem somewhat incremental to me. So yeah, it's really interesting. So let's talk about, okay, you're an engineer, you're a designer, your employer, your bandwidth will never, ever allow you to get into a shop. So the other thing I wanted to kind of play with you today is to talk about maybe a little bit of myth busting to help kind of give some, so if you're just going to be able to go to a board fabricator's website, say, and you're kind of vetting them by, customer reviews and their website. Okay, there's one thing that's like a pet peeve for me, because talk is cheap, and a lot of board shops have these things where you can go on and see what their capabilities are, and it'll have like, their standard capabilities, they're like bleeding edge capabilities, and then what's on their roadmap.
Right.
And I feel like I've worked for enough board shops where I feel like, oh, well, I'm going to let you bust that myth, buddy. Go ahead. What do you think about those? And how trustworthy is that data that most board shops put out there?
Well, I can talk about our own company, and I have no problem poking fun at ourselves.
Okay, poke away.
I can't remember the last time our website was updated, to be honest. And that's probably true of most PCB houses. They make a new website, they put some number on there, and you just forget about it. And lo and behold, You got PCB designers reading your website, a couple years later. They're like sending in data that reflects exactly what your website says. And then you're like, well, no, that's not right. Or, do it this way or whatever. And they're like, but it was on your website. Yeah, but you just spent 3 weeks designing a circuit board without talking to anybody because of what was written on our website. It's not common sense. I mean, verify. Trust but verify.
But, is it? We are so glued to our screens and we read stuff like it's gospel. Yeah. And you know what bugs me about those websites? Yeah. So, here's the takeaway, listeners. Yeah. Pick up the phone, because I wouldn't trust those websites. And another thing I see is, Sierra's an established shop. They know what they're doing. You don't stay around for 30 years unless you're doing something right. There might be a significantly smaller shop, but that has a really shiny website. And then they put up this roadmap, and they're nowhere near that bleeding edge number or that roadmap. It's marketing. It's marketing. So, the myth busted is, do not trust the website. Pick up the phone.
I think I saw an ad from some shop. It's like, everything in our factory is done by robots and artificial intelligence. No, it's not.
Liar.
No, it's not.
Pants
on fire. You can say whatever you want on the website. That's not true. It can't be true.
It's not true.
It's not true. And then the other one is, when you're talking about HDI and stacked vias, I think I saw an ad one time, it's like, we do 10 stacked vias. I'm like, okay, maybe you did that one time and that board didn't turn out so good.
Yeah, right.
Yeah, so it's not something that everyone should be doing. Actually, let's do a myth bust, right? PCB materials, they really only hold up to like maximum 3 to 4 laminations. If you have more than that going on in your board, you should be very, very worried. That material is going to break down. You're going to have all sorts of issues in the field. It's just not good. I don't care what material vendors say. 3 to 4 laminations is it. Like, that's the max.
Because of the thermal stress?
Exactly. Because remember, a PCB, this is the isolation and silos we're talking about. Uh-huh. A PCB material manufacturer, right? Uh-huh. They really only care to a point of PCB manufacturing, right? Do they really care to the point of assembly? They don't. They're not talking to assembly shops. Hey, the board got made. We're good. You're able to etch. You're able to drill. The wicking isn't too bad. There's not too much capping going on. Our materials meeting electrical performance properties, all measured on the circuit board. Oh, fantastic. We're done.
And by the way, how are those tested? In a lab.
Exactly.
In a laboratory environment, they may make test structures to test all that out, and I think they do a pretty good job. But still,
no,
it's not a real board.
It's not enough.
So anyways, that's a good myth bust. That is a good one. So 3 to 4, that's your number.
3 to 4, and since we're on PCB material manufacturers' cases, don't trust the data sheets, even for the electrical properties. We don't trust the data sheets in terms of manufacturing, because one material performs completely different than another material, even if it's an FR4. To Isola's credit, our main PCB material is 370HR, because that PCB material is so much better than the Chinese stuff, the Ventec or the Nanya. Those materials are notorious to move around like crazy and they're just bad materials. They're not consistent. 370HR from Isola, that is super consistent, and so that's our default material. Okay. It costs more. Of course, you get what you pay for. It costs more, but it's going to perform so much better.
Okay, I was going to ask you this. This was going to come up like 2 points from now, but I'm going to ask you to do it now.
Sure.
Because this is a myth bust that I want to handle too, is that price and value are not equal, and that Yeah, see how you're laughing there?
Yeah.
Because you have to look at the total cost of ownership, TCO,
Yes.
right? And so, people might flinch at you saying, oh, that sounds good, Isola, stable. Okay, I'm going to use that from now. Oh, wait, it's more expensive. But if you're having field failures, wouldn't it be, which costs you a boatload of money?
Exactly.
Would you rather pay a little bit more,
Right.
For a material or a process or something?
Right.
So just go ahead. Just have a little therapy on me. Price versus value. Where are things you see people, where do we get hung up?
Yeah, I think that the smart companies have a total cost of ownership understanding. They have an idea that, how much is something costing them, how much is bad quality costing them. They do have a sense of that. Good facilities, good startups, as we're working with them and they're growing, if they're hiring the supply chain person first and putting pricing pressure on their vendors, versus are they hiring a quality department first and putting quality pressures on their vendors? Like, which one are they doing first? That tells you a lot about their culture and what kind of product they're trying to make. Supply chain has its place. Everyone has, cost
Absolutely.
targets. But is that the first thing as you're developing as a startup where you should focus on? Is that really the first thing? Or trying to make a quality product and a good name for yourself? Is that the first thing? I mean, this is the culture of the company. So
right. That's a really good point. And I'm sure you see a lot of that being smack in the middle of Silicon Valley with a lot of startup activity.
There's a lot of startup happening here, and which is good. And not everyone makes it; they just don't. And it can be for a lot of reasons. But guess what? I feel very strongly from what I've seen that for people in the electronic space, the number one reason is not attention to detail and to quality. So if you spend all this time and effort and money, launching a product, and it's just so-so. In terms of quality, I mean, you just shot yourself in the foot. And all that investment is just basically gone. I mean, that's what it is. So I feel strongly about that. Now, the other kind of thing that people say, which, since we're talking about therapy, they say, well, quality is a given, so get your price 10% lower.
No, it's not.
I'm like, okay.
It may be given to you in your mind. I mean, I don't mean to be facetious, but don't assume quality.
Yeah.
I think that's not a good assumption.
No, and going back to why tour a facility, our cross-section lab is literally in the center of our PCB fabrication company. The cross-section lab is, how we make sure we're delivering good quality product to our customer. Whether they ask for a cross-section or not, we've cross-sectioned that product as it's going through all the manufacturing steps. So we know, hey, something doesn't look right here. Let's stop it before it escapes to the customer.
And in those cross sections, I'm sure you're looking for the continuity of plating in the hole, maybe the wrap being. What else are you looking for in those cross sections? Yeah,
I'll send you a write up on cross sections.
Okay, all right. We'll put that in the show notes.
Yes.
Okay, awesome. Well, you talked about, do people make PCBs or do robots? Now, the answer is kind of both, because say in a really decked out plating facility, you might have robotics, right? Taking, big panels, down a line in a timed format. And so in that case, they are being plated. With human assistance, of course, of those machines being programmed and so forth. But, there is still a really important place in the world for visual inspection, right? Not just AOI, right? And there's things that people can do that robots can't still.
Yeah.
And so talk about that a little bit, human versus robots, how much?
Yeah, so our business again is high mix. So I mean, we're processing so many unique designs every day. And then there's those designs that, they're super standard, no problem. No one has to really think about them. Then there's designs that are kind of in the middle where, we need to look at it a little bit, but, still we've done it so many times, not a problem. And then there's designs that are kind of towards the edge, like I would say edge cases, where, they're trying a different material, like a Rogers, let's say 4000. They have, staggered microvias, via and pad, plated over. They have like a few things going on in that design. Those designs don't just flow through any PCB fabrication shop. They can't, because how many designs in the world are going to employ all those special features? Again,
in one design, right?
In one design. So, again, back to the myth busting. Just because your website says you can do a 4 mil laser drilled via, is that good for every material type? No, it's not. And same if you go even smaller, like a 2.5 mil laser drill or a 6 mil mechanical drill. Are these good design criteria for all material types? The answer is no. So you have to understand that, the different capabilities play off of each other, and you can't describe every single interaction, because we don't know what designers are going to design.
I always try to stand in the shoes of our listeners, and some of this can sound overwhelming, like, wow, I could really understand how that might work on one material, but I use 6 different kinds of material. I have to be an expert at all that. I don't have time. So, what's the takeaway? Like, okay, so I'm a designer. I want to get more educated. Okay, I'm going to pick up my phone. I'm going to go visit my board shop.
Right.
Which part can I just leave in your hands to take care of me, Amit? Right. And which part is important for me to know? It seems sort of overwhelming. Right.
Yeah. So, Judy, I'm not young anymore, and what I've learned is every good relationship starts with trust. Right. So it really has to do with that. If you have the opinion that every board house is the same, every assembly shop is the same, and you want to treat everyone that way, and you don't really want to establish any sincere relationship with one or two, then you got trust issues. And, you're going to try and, keep everything yourself and own everything, and somehow in your mind think that, because I spec'd it, shop A can build it, shop B can build it, shop C can build it, I should be fine. And that's just not true. It's about the trust and, understanding what your fabrication house and assembly house can do. And if you trust them more, then you start, feeling, okay, I can have the fabrication house own this part. Because they are the experts. They do this every day for 30 years. Let them own it. So like arrays, for example. I mean, have your fab house put together an array. Hopefully they know about assembly as well, and they can own that array for you. That's what we talked about at the beginning.
I think you just hit on a gold mine, quite frankly. And often I've said, this idea that relationships really drive the trust, and the relationships really is the engine that makes things go. It's something we don't talk about in our industry a lot because we're so technical, and I think it's something that's got a little lost and tattered in our digital world. Right. And it's something that I'm very passionate about. It's why I do this podcast, because I think relationships are key to so many things that we do in this highly technical world we live in. And Amit, good for you, because I couldn't agree with you more. And I love your saying it, because sometimes I say it and I get dismissed, I think, because I'm a woman. And
oh, come on, don't.
No, I swear this happens. It does. No, but I love that you're saying it, because And I'm not complaining about that. I'm not crying, me too. I'm not going there. What I'm saying is it's easy for someone to think, oh, well, of course you have, to sort of stereotype and think, well, you're a woman, of course you think things are driven by relationships. But I don't think it's that simple. And you just said it really, really beautifully. So
thank you.
High five. Love it. And I think that's true. Yeah, high five. So I think, so I think the important thing is you establish that comfort level. And to do that, you do have to actually build a real relationship, and that isn't going to be perfect because, but you're going to build enough trust to where it's like, okay, I know they're going to raise a flag.
Yeah.
If I'm speccing a 4 mil hole on the wrong material, I know Amit's going to call me, right? Or they know someone's going to call me and raise the flag. Absolutely. And you have to have at least that base trust, and without, having some face-to-face interaction.
Right. Trust is key.
I love that. I want to take a little side trip here.
Okay.
Also, the reason why I have the great privilege and joy to have 2 years ago started Altium Live for Altium, which isn't just for Altium users. It's for anyone who designs PCBs, right? And I heard through the grapevine Sierra's gonna be present, which I'm very excited about.
Absolutely.
So there is a place, people. We can put, the rubber, where the rubber meets the road. You can actually come talk to Amit and others who fabricate and start building those face-to-face relationships in an environment where you're also learning about design. So there's my little plug for Altium Live and for Sierra Circuits.
I have a plug as well.
All right.
So
plug.
I know we talked about visiting your facility a lot. And of course, some people have travel restrictions or travel budgets, minimal travel budgets. So we are going to release something like a Google Maps for Street View for like our facility. So you could literally kind of click through and walk through our facility.
That is so cool.
When that's ready, I'd love to send it to you if you could put it in your notes for the show.
Okay.
People can kind of click through and look around.
Would you ever let us come film in your facility?
Of course, yeah.
Because we keep talking to our guests about that. We haven't, but that's something I always, even back when I was selling boards, I always thought, it's the digital age, people. Why can't we do a video survey of a facility and explain to people, and they can ingest it? Again, you cannot completely source out having no relationships, but I still think it's a way if your travel budget is restricted. I love the Google Maps idea. So that means you can look at it like in 3D, and like you can turn to the right and see this and turn to that is super cool. That's something
virtually walk through the facility.
That's awesome. I love that. Will it give you information about what you're looking at?
Oh, absolutely, yeah. That's the idea.
So when's that going to be done?
I think in about
someday.
About 3 weeks we'll be done with that.
Oh, great.
So it might be just in time for this podcast.
Okay, well, if it comes out, I bet you will come out before this podcast. So if you have it, let's put it in the show notes. That would be very exciting.
Awesome. Yeah.
Okay.
We'll do that.
Awesome. I love that you're doing that. Good job. Before we sign off here, two last questions for you. One, are there any trends you're noticing sort of in technology? Are you noticing, an uptick in more flex, or, more multi, lamination? Are you seeing an increase in HDI? Anything like that you're sort of noticing, at least from your seat there at Sierra? Everything you said actually is definitely a trend. People are trying to do things smaller, so that's where HDI comes in. So we are seeing a lot more HDI.
Most fabricators in the U.S. should have a laser drill machine and should be able to perform that. So that's like kind of I would say in the past where it wasn't like everyone's cup of tea, it should be now. It should be.
Okay.
And we see a lot of customers, venturing into HDI, which is great. And then also same with flex and rigid flex. If you're building a device and it has a ton of cables in there, you might want to think of total cost of ownership and think how can a rigid flex design help in that manner. So this is rigid flex and flex, that's total cost of ownership is a really key point. The individual part, if you compare 3 rigid boards to 1 rigid flex, probably the rigid flex will be pretty expensive, maybe equal in cost, definitely not less. Well, so why do that? Well, because you have a more reliable product.
Right. Why
does the military have a ton of rigid flex requirements? Because, connectors can fall off a circuit board, no matter how well they're put down. So, there are reliability reasons to go with a rigid flex, especially in the automotive space. Rigid flex is becoming more popular and should be, used instead of like these weird cables that, go on forever. So
right.
Think of total cost of ownership for that. And, these technologies, HDI and flex and rigid flex, they have different design rules, not so bad. They have different, you need to understand it is a different technology. So the issues that you faced when you first started building, single lamination multi-layer boards, you're going to have some issues that you kind of tweaked out. When you get into HDI or rigid flex, there's going to be some initial issues that you just have to power through. It's never going to be perfect. You're doing something that's different or for the first time, and that's where Sierra can really guide you, or any other board house and assembly house can really guide you. It's, we've done a lot of different designs. We know what works, what doesn't work. Try and take the advice of your fabricator and your assembly house so that, you can, minimize your mistakes. There'll still be mistakes because you're building something unique.
Right.
No one's ever built that product before. So you're going to encounter things, but, just try not to commit all the mistakes in the world.
Right.
All the rookie mistakes. So talk to your fabricator, talk to your assembly shop.
Okay.
And get a tour.
Awesome. And I'm sure that you would welcome any of our listeners that happen to be in your area or whatever to come visit your shop. So I would recommend that for our listeners. Well, I think we have covered a lot of territory today and really meaningful, good, meaty stuff. So thank you so much, Amit, for joining us and taking time out of your busy schedule. So thank you to Amit and Sierra Circuits for joining us today. Thank you for our listeners for listening. Hey, you guys, please like, subscribe, comment. We want to give you what you want to learn about. So please remember to subscribe and give us your feedback. We'd love to hear from you. Until then, always stay on track.